Maps do not exclude time, but they do in general subordinate it to space. In the 18th century, ubiquitous adaptation of the systematic grids of longitude and latitude could predict, like a calendar, the indefinite extension of space into realms unvisited by the old world navigators, terra incognita, as you can see at the bottom of the Mercator map here. This was the first step towards the absolute map. The second belongs to the digital summer of the three great media of modernity: accounting, filing, and mapping, geographic information systems, or GIS for short. GIS compiles the data we have on populations and maps it against environments. When Foucault speaks of power mediation between populations and environments, he might almost have been speaking about these massive software suites, where not only what we know, but extrapolations from the present into the indefinite future, or imaginary future, are organised into communicable calculations. That's the art of simulation in the terms of geographic information systems. GIS allies the powers of these three media with the calendar to provide the perfect instrument of rule, a simulator of consensus and dissent, of conformity and risk, whose product is a statistical predictor of changes to be avoided or managed. GIS is a machine for ensuring that the future looks as much like the present as the embrace of human and technology can devise. In a sense, the residue of cartography is only a metaphor for two entirely characteristic operations: the arithmeticization of knowledge and its spatialization. All possible futures lie spread out as so many Feynman diagrams or forking paths, each of them open to the managerial rule of biopolitics. The grid of spreadsheets and database cells, of stacks, of map coordinates, of calendrical dates, is a characteristic diagram, as Deleuze would have it, of digital media today. The array of raster display and of CMOS and CCD cameras, LED, LCD and plasma screens, DLP and LCOS projectors, the matrix principle in storage, the grid of QWERTY and calculator keys, the linear arrays of scanners and printers, all of them in Peter Lunenfeld's nice phrase, snap to grid. At the heart of the grid is the triumph of space over time, or rather the spatialization of time. Time is a mysterious thing. Augustine observed in the 5th century that as long as no one asked him to define it, he knew perfectly well what it was. But if they did, he didn't. Once upon a time, time was on the human side of the population-environment equation. Very gradually, time migrated to the environmental side, something that stands over against us, in the way our tools became factories that dominated and constrained our actions by moving over to the environment side, from the human to the environmental side, becoming second nature. To use a now rather old-fashioned term, our tools were alienated from us, and now time has been alienated too. Now, alienation has an important legal meaning as well as the sociological one. Something is alienable if it can be sold, or given away, or otherwise gotten rid of. Slavery is illegal because a human life is not nominally alienable. To say that time has been alienated, then, can be construed as meaning time, like factories and now like information, can be sold. When we speak of political economy, we mean the inextricable movement of economics and politics. The pseudoscience of economics, when it's abstracted from politics, has resolutely failed every test. At the same time, politics without economics has no traction as an explanatory system. Most of all, neither has any actuality unless it is grounded, as we've seen, in the mediations of material media. The alienation of time, its placing over on the side of the environment, makes it necessary, as Foucault suggests, that political economy should mediate alien time back to the population. The instruments through which it does this are the media technologies whose history I've just been sketching: spreadsheets, databases, and GIS. So what exactly happens to time in the media technologies of the neoliberal database economy? Time shares the arithmetic properties outlined above. Time occurs in... Oh, sorry, this should have come up a bit earlier. There's an example of a grid. Not just in software, but in mapped right down at the hardware basic process of digital imaging. Just fortuitously, this is a CCD chip, standard 35mm CCD. Now, the lens is open for a fixed duration, during which photons are flooding in from the top of this diagram. Where they strike the pixel array of receptors, the photons cause reactions which release electrons. The electrons en masse are what we call charge. To get charge off the chip, ready for the next image to be taken, and of course for them to be turned into voltage and then digitized, they have to be drained into some sort of storage. The design of the chip ensures that the charge will always flow in channels in a specific direction. So these are the channels you can see between the N plus and N minus. That those charge zones in the chip ensure that the charge produced by the photons will drain down the channels that are coming towards us in this picture. So these are sort of like the columns of the future image, the raster array in the future image. The problem, however, is the rows. And the solution is to have the charge from each row cascade down the column in strict lockstep. And for this, you get first the pixels from row 1 come off and then stored, row 2 stored, row 3 stored, but they have to come off synchronously. This requires a clock function. Incidentally, writers complaining of the death of cinema have missed this difference between analog and digital images, concentrating instead on a somewhat bogus argument, I believe, about realism. The real distinction between the two is that analog images only succeed one another in time, whereas digital images, electronic images in general, change or contain time in the structure of each individual image. The time they contain was, of course, worked out in the succession of cinema frames and in greater detail by the scanning function of interlaced TV and analog video. But the soft blur that you can see in this 1964, I think, image from Doctor Who, this soft, blurry cathode ray tube image gives way to an ontological secret which cinema's photographic basis has hidden. No electronic image is ever complete. Even the startlingly fast refresh rates of progressive scan high-definition screens cannot disguise the fading of each image before the successor scan begins. It's this fading which drives television towards 24/7 broadcasting. There's no point in time in which broadcasting is actually complete and has come to an end in the sense of an ending. The indefinitely extended future of simulation, the pseudo-virtual science of risk avoidance, allows no such satisfaction. And I mean pseudo-virtual here in, again, a rather technical sense. That pseudo-virtuality plots the knowable outcomes of known trends. The real virtual is the open becoming of unknown futures, which is where I want to end today later in the presentation. The endlessness of transmission is a quality of the pixel as an automated aggregate atom of perception, the flicker that enchants the eye, the essence of distraction. I don't think the optical illusion is quite going to work here, but those of you who know animal this Merriweather cover will know that this has a rather enchanting vibration effect when you see the physical object. The essence of distraction, which has exercised commentators on modernity from Benjamin and Krakauer to Jonathan Crary. Historically, the function of editing was to structure flux by interrupting it, changing space and continuity cutting, but also structuring the experience of flux into discernible scenes that succeed one another. Distracted gazing at flux is like watching waves. Cutting, which separates figure from ground and one scene from another, is a mimesis of the concentrated gaze that selects the telling detail and constructs a story, or at least a temporal direction, from the manifold of perception. That process of informing flux is now undertaken at a far smaller pre-human scale, pre-perceptual scale. Though tiny, the pixels of a camera or a projector chip are actually finite in dimension. The duration of exposure is also tiny but finite. Where pixels are atoms, photons are quanta. And the individual pixel in an individual exposure is an aggregate of all the photons raining in on them, their wavelengths as well as their numbers. The result is an average, reduced to the counting units of hexadecimal colour numbering. The ordering of time thus occurs not at the level of the frame now, but of the pixel. In addition, most codecs use a form of prediction to reduce redundancy in the signals they transmit. When a block of 4 pixels, a group of 4 blocks, or a less regular slice is made up of pixels of more or less the same colour, the codec reduces them all to one numeric code. If they stay more or less in the same place for the duration between keyframes, the data transmitted instructs the display to maintain that colour throughout. So what gives you that blockiness when you've got a poor DVD transfer, for example. Or if you're looking at YouTube videos blown up to full screen. Nothing emerges in those spaces. Nothing evolves or changes in that duration. The ideology of efficiency, now embedded in the very media through which increasingly we learn about the world, reduces change to its minimum. So 4 principles are in play. The statistical averaging of captured light to a single figure, the use of unit counting, the clock function as a way of regulating the pixels in this instance, and the predictive tools that minimize change over time. The digital image rejects space, but time is diminished. Sorry, it respects space. It respects space. I'm going to need a drink of water. But time is by no means redundant in digital systems. For example, in packet switching. It's a foundation of the TCP/IP suite and increasingly for other kinds of digital broadcasting. The basic idea is simple. Every message, whether it's an SMS or a multimedia file, is split into smaller packets that find their way through the network to be reassembled at their destinations. The problem is this: messages sent out into the network have a limited lifetime. Otherwise, the millions of fragments of undelivered messages, all those 404 errors and all the undelivered emails, will clog up the system. Likewise, if things persist, if datagrams persist in time, then you can't update them swiftly enough. You know, data that lasts for 24 hours will stay cached for 24 hours. So you have to have a restriction on the duration that these things can persist. Packets are therefore designed to contain not just data, but a complex envelope, which I've diagrammed here, which includes the key data for its transmission, as well as sender and receiver address. Each packet contains information on its position in the whole message, how many packets there are, which one is included in the present item, and finally a kind of clock, listing the number of nodes it can pass through on its way to its destination. As it passes through each node, that number is reduced by 1, until, if it fails to arrive, the number reaches 0 and the packet erases itself. This is what network engineers used to call until IPv6, TTL, the time to live. I don't have to tell a room full of artists about the richness of the